In this episode, we look at data types and data states, which are two simple ways to think about what information is and what is happening to it. Security controls become much clearer when you can answer two questions. What kind of data is this, and where is it in its life cycle right now? Data may be neatly organized in a database, or it may be scattered through documents, messages, recordings, images, and notes. Data may be sitting in storage, moving across a network, or being actively processed by an application. Each situation creates different risks. You cannot protect every piece of information with one generic control and assume the job is done. A file stored on a server, a customer record being edited in an application, and a message moving between systems need different kinds of protection. You are learning how to match security thinking to the form and state of the data. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at CyberAuthor.me in the Bare Metal Study Guide series. Structured data is information organized in a predictable format. You can picture rows, columns, fields, tables, and records. A customer database might have one field for a name, another for an email address, another for an account number, and another for a billing status. A payroll system might store employee identifiers, pay rates, tax information, and deposit details in defined fields. Structured data is easier for systems to search, sort, validate, and report on because each piece of information has a known place. That structure can be a security advantage because access rules, retention rules, encryption, and monitoring can often be applied more precisely. If the organization knows exactly which database column contains social security numbers, it can focus strong controls on that field. Structured data is not automatically safe, but its organization can make it easier to discover, classify, protect, and audit. Structured data often lives in databases, business applications, spreadsheets, directories, and transaction systems. It supports work that needs consistency, such as account management, inventory, billing, identity, customer service, and reporting. Because structured data is easier to query, it can also be easier to misuse if access is too broad. A person with permission to run reports may be able to export large amounts of sensitive information quickly. An application account with excessive rights may read more records than it needs. A poorly protected database backup may contain the same sensitive fields as the live system. You should think about structured data as both organized and valuable. Its predictable shape helps defenders protect it, but it also helps attackers understand what they have found. Controls often include role-based access, field-level restrictions, encryption, logging, input validation, backup protection, and careful control over exports. Unstructured data is information that does not fit neatly into fixed fields or a predictable table. It can include documents, emails, chat messages, presentations, images, audio recordings, videos, scanned forms, support notes, design files, source comments, and free text reports. Unstructured does not mean useless or chaotic. It means the information is not organized in the same strict way as a database table. A legal document may contain names, dates, payment details, contract terms, and confidential strategy all in the same file. An email thread may include customer information, internal decisions, attachments, and informal comments. A recorded meeting may contain sensitive discussion that is not obvious from the file name. Unstructured data is difficult to protect because sensitive content may be buried inside normal business material. The system may not know what the file contains unless it is scanned, labeled, reviewed, or classified. Unstructured data tends to spread widely because people create it constantly while doing normal work. Someone writes a report, downloads a spreadsheet, attaches a file to a message, saves a copy to a shared folder, records a meeting, or takes notes in a collaboration tool. Each copy may create another protection problem. Sensitive data that began in a controlled application may end up in a presentation, screenshot, email attachment, or personal download folder. That movement makes classification and access control harder. A document library may contain public announcements beside confidential financial plans. A chat tool may contain casual messages beside incident details or customer information. Security teams often use data discovery, content scanning, labeling, access reviews, retention rules, and data loss prevention (DLP) controls to reduce this risk. The goal is not to stop people from working. The goal is to keep sensitive content from becoming invisible. The difference between structured and unstructured data affects how you search for it and how you protect it. With structured data, you may know that a certain database field holds account numbers, so you can apply a specific rule to that field. With unstructured data, the same account number may appear in a document, image, message, or note. That means protection often depends on content analysis, metadata, file location, owner, classification label, and user behavior. Structured data may be easier to validate because the system expects a certain format. Unstructured data may require more review because meaning depends on context. For example, the word confidential on a document may be a label, a topic, or part of a sentence. Security design should not treat these data types the same. The more predictable the data is, the more precise the control can be. The less predictable it is, the more discovery and governance matter. Data at rest is data that is stored somewhere. It may be on a hard drive, database, file server, cloud storage service, backup tape, mobile device, removable drive, archive, or storage volume. At rest does not mean unimportant or inactive forever. It only means the data is not currently moving across a network or being actively processed at that moment. Stored data is often a major target because it can contain large collections of valuable information. A database at rest may hold years of customer records. A backup at rest may contain copies of many systems. A laptop at rest may contain cached documents, saved reports, or downloaded email. Common protections for data at rest include encryption, access control, physical security, backup protection, retention limits, secure deletion, and monitoring for unauthorized access. The main question is who or what can read the stored data and under what conditions. Encryption is one of the most common protections for data at rest, but you should understand what it does and does not do. Encryption transforms readable data into a protected form that should not be understandable without the correct key. If a laptop is stolen, full disk encryption can help prevent someone from reading the stored files directly. If a database backup is copied, encryption can reduce the chance that the backup contents are exposed. But encryption does not solve every problem. If an authorized user signs in and has permission to read the data, the system may decrypt it for that user. If encryption keys are poorly protected, the attacker may go after the keys instead of the data. If data is exported into an unencrypted file, the protection may be lost. Encryption at rest is powerful, but it must be combined with key management, access control, logging, and careful handling of copies. Data in transit is data moving from one place to another. It may move between a user and a website, between an application and a database, between two cloud services, between branch offices, through an application programming interface, API, or across an email system. In transit, data may cross networks that the organization does not fully control. That creates risk because attackers may try to observe, intercept, redirect, or modify traffic. Protections for data in transit often include encryption, secure protocols, certificate validation, trusted network paths, and integrity checks. Transport layer security, TLS, is a common way to protect web and application traffic in transit. A virtual private network, VPN, may protect traffic over an untrusted network. The idea is to protect both secrecy and trust while data moves, so the recipient can have confidence that the information was not exposed or altered along the way. Data in transit can be misunderstood because people often assume that if a system uses encryption somewhere, everything is safe everywhere. The real question is where the protection begins, where it ends, and what happens at each point along the path. Data may be encrypted between your browser and a web application, but then move inside a cloud environment, pass through a load balancer, or be sent to another service. Each handoff matters. Misconfigured certificates, weak protocols, expired keys, unapproved forwarding, or insecure application connections can weaken protection. Email creates another challenge because a message may pass through several systems and may be stored at multiple points. Secure architecture maps the full path of sensitive data. You should know which systems send it, which systems receive it, whether it is encrypted, whether integrity is checked, and whether logs reveal enough to investigate suspicious movement. Data in use is data that is actively being processed, viewed, edited, analyzed, searched, decrypted, or used by an application. This state can be harder to protect because the system often needs the data in readable form to perform work. A database may store encrypted records at rest, but an application may need to decrypt a record to display it to an authorized user. A spreadsheet may be protected on disk, but once opened, the data appears on the screen and may be copied, printed, captured, or pasted somewhere else. An analytics tool may process large datasets in memory. A security tool may analyze logs containing sensitive details. Protections for data in use include strong authentication, authorization, session controls, application security, memory protections, screen handling rules, endpoint security, monitoring, and limiting what users can do with displayed or processed information. Data in use is where many policy decisions become practical. A user may be allowed to view a record but not export it. A support representative may be allowed to see partial account details but not full payment information. An analyst may be allowed to run a report but only on a limited dataset. An application may be allowed to process sensitive information but not write it to debug logs. These decisions matter because once data is being used, it can easily move into a new state. A viewed record may become a screenshot. A query result may become a downloaded file. A temporary processing file may become stored data. A copied value may move into an email or chat message. Data in use is active, and active data creates opportunities for mistakes. Good design limits unnecessary exposure during use and watches for actions that create new copies or new risk. The same piece of data can move through all three states during a normal business process. A customer enters information into a web form, and the data travels in transit from the browser to the application. The application processes it in use to validate the request and create an account. Then the data is stored at rest in a database. Later, an employee opens the record, placing it in use again. A report exports it, creating another stored copy. The report is emailed to another team, placing the data in transit again. That team saves the attachment, creating more data at rest. This movement is why security architecture needs lifecycle thinking. You do not protect data only once. You protect it as it is created, transmitted, processed, stored, shared, archived, and eventually deleted. Every transition can create a new exposure. Data type and data state also connect to classification. Personally identifiable information, PII, financial records, health information, intellectual property, authentication secrets, and security logs may each require different handling. Whether that data is structured or unstructured affects how easily you can find and control it. Whether it is at rest, in use, or in transit affects which protections make sense at that moment. PII in a structured database may be protected with field-level access and encryption. The same PII inside an email attachment may require DLP scanning, secure transfer, and retention controls. A secret stored in a vault is one problem. A secret displayed in a log or copied into a ticket is another. Classification tells you how sensitive the data is. Type and state tell you what practical risks exist and which controls are likely to help. Data protection becomes stronger when you stop thinking about data as a single static thing. Structured data is organized and easier to query, but that also means it can be extracted quickly if access is weak. Unstructured data is flexible and common, but sensitive content can hide inside ordinary files and messages. Data at rest needs storage protection, encryption, access control, and lifecycle management. Data in transit needs protected channels, trusted endpoints, and integrity checks. Data in use needs careful authorization, secure applications, endpoint protection, and limits on copying or exposure. These categories are not just vocabulary for an exam. They give you a way to reason through real security decisions. When you see data, ask what kind it is, how sensitive it is, where it is right now, where it is going next, and who or what can touch it along the way.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.